Hi. Okay, so by now we have designed many projects in VHDL and we implemented them in FPGA board as well. And now we will be talking about one of the most important part of designing process, and that is testing or verification of your designs. So we have many different type of simulation tools to simulate our VHDL designs. And you can test your VHDL designs by changing the values of your input ports, and you can see if you're getting the right result or not. So this is a manual approach of testing. However, VSDL allows you to automate this testing process, and we use test benches for this purpose. There are many different options available for writing these test benches in VSDL. For example, you can specify that what values you want to test at what time. You can also test your designs by reading the inputs from a text file. So it will read the data from the text file and will use it for the test values. You can also write your output to some text file as well. And later you can verify the results as well. So there are many different ways to test your designs and we will be talking about them one by one. So first understand what is test bench. So test bench is a VSDL module itself, and we need to write a separate VSDL code for these test benches. Test benches has two major tasks. First is test benches provides the input values to your VSDL designs. And second is that it ensures that your output of your VSDL design matches with the correct and expected results. Test benches are very flexible and you can control that what test you want to perform and for how much time. So this is a basic structure of your VSDL test bench. We have this DUT, or you can say device under test. Sometimes we will also say it UUT, or unit under test. Basically, this is your VSDL design, which you have written and you wanted to test. Okay. So this device or this design will have some input ports and some output ports, right? Now, do you see this block of gray color? This you can assume like your test bench. So what we will do that we will instantiate our VSDL design to this DUT inside this VSDL test bench module, just like how a component instantiate. So this DUT model is like a component of this test bench. Okay. If you notice, you will see that we have not defined any input output ports for this test bench. So we have input output ports for this DUT model only, but we do not have any input output port for this test bench module. Okay. Because we are driving these input ports of this DUT inside our test bench. And then based on these input values, we get our output from this DUT model. And finally, we will compare these results. Means we drive all the input ports of this DUT inside this test bench. And for this, we write our VSDL test bench code. And you can use VSDL process, VSDL procedure, VSDL functions, or any other VSDL module, or even some combination logics to drive these input ports. Even you can read this set of inputs from some text file, which you can import into your test bench. VSDL can also create a text file to store your output data, and it captures all the logs of your output so that you can verify the results later from that text file. Even test benches can print messages on your simulator console window, and you can print any message in your simulator console. For example, some error message or some warning message or even some kind of note. And this is very important because you can print a message if some error has encountered. So you know that what is the problem. This is a simple VSDL syntax for printing a message on your simulator console. So we start from report keyword followed by your message inside the double quotes. And optionally, you can also tell the severity label as well. So these severity labels are note, warning, errors, and failures. And you have to write them exactly like this. And if you're not defining any severity label in your message, then it will be by default considered as note severity. Okay. So VHDL syntax is report, message string, then severity, severity label, semicolon. Now, these are the few examples of reporting messages. So, first is report. This is a message. Now, because we have not specified the severity level, so this is by default considered as a note message. Now, second example, report. This is a warning. Severity, warning, semicolon. So, this will print. This is a warning message with the warning severity. Okay. Now, important thing is that if in any case error or failure is reported by the simulator, then your simulator will print that message and then it will stop simulating. But if you get a warning message or a note message, then simulator will print that message but continue the simulation. Okay, so remember these differences between warning note messages and error and failure messages. Now, once we provided the input to our VHDL design or DUT and we get the outputs, then we need to validate these outputs, right? Like if they are correct or not. So we have these assert statement to validate our output. So this is a kind of Boolean condition and it will print a message in your simulator window if the condition is not met or if the condition is false. For example, you can compare your expected output with your design output. And if both are the same, means everything is good. But if they are not same, means there is some problem in your design, right? So assert can print a message in your simulator window that your output is not correct. Something this kind of message. So this is the syntax of assert statement. Assert condition report string in double quotes severity severity label semicolon. For example, assert overflow is equals to 0 report message overflow severity warning semicolon. So what it will do that until your overflow is logical 0, everything will fine. Means until this condition is true, it won't display anything. But as soon as overflow is detected and this condition get false, means your overflow triggered logical 1, you will get this message overflow. And that's have the severity of warning. Now, as I said, test benches can also read a text file or even write into a text file. So for that, first we will need a library std and we need to declare text IO package from this std library. And then you can use text file to read data from it or to write data into it. So we can store set of inputs into the text file. Then testbench will read this file line by line and perform the task on these set of inputs. And after getting the results, it can write the results into the output text file as well. So this is really a powerful tool because now you can change your input set just by updating the text file. Instead, writing different set of inputs into the test bench itself. So you can test your design by using many multiple set of input combinations. And you can leave your simulator running for a long time. Like you can leave it for a whole day and you can perform as many tests as possible. Now understand how we do this. So this happens in 4 steps. First, we open a file. Second, we read from a file. Third, we write into a file. and finally we close the file. So for that, we need to declare a text file as variable before we open it. This is an initial step or a prerequisite, you can say, and we need to declare it either inside the declarative part of architecture, means between the architecture statement and begin statement, or you can declare it inside the declaration part of a process block, means between the process statement and begin statement. So this is a syntax for declaring a text file in VHDL. We start from file keyword followed by the file handle and then specify the format like text. This file handle name is actually a variable in VHDL which will be used for input output operations later. So the syntax is file, file handle, colon, text, semicolon. Like for example, file, file1, colon, text, semicolon. So we have created a text file named as file1. Simple. Now, once you declared your file in VHDL, you can open it now. So this is your VHDL syntax to open a file. File open, bracket, file handle, comma, file name .txt, comma, open mode, semicolon. Now these open modes are read mode, write mode, and append mode. So we use a VHDL function file open to open a file. Then inside the bracket, we give the file handle name and then file name inside the double quotes. And finally, you specify the open mode. Note that each element is comma separated here. Like for example, first example is file open bracket file1, comma, input vector .txt, comma, read mode, semicolon. So you may guess it will open a file with file1. Name of text file is input vectors.txt and it will open in read mode. Second example is file open bracket file2, comma, output vector.txt, comma, write mode, semicolon. So this will open a file with file2. Text file name is output vectors.txt and it will open in write mode. Don't worry if you are not clear about it at the moment, because I will show you that how to write a VHDL code for reading data from a text file and for writing data into a text file in the separate session. But this is just pretty basics. Now this is our final step, that is closing the file. So this is pretty simple. This is the VHDL syntax for closing a file. Simply write file close, file handle, semicolon. So we use VHDL function file close followed by the file handle and then semicolon. For example, file close, file1, semicolon, file close, file2, semicolon. Okay, so that's it for today. In the next session, we will look into the VHDL code, that how you can write data into a text file in VHDL. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.